When you picture Saturn, you picture the rings. They look ancient, timeless, like they've always been there. But here's the twist. Sharks were already hunting in Earth's oceans before Saturn may have acquired its famous rings. Sharks aren't just older than trees and flowers. They may even be older than Saturn's iconic rings, and their lineage has survived nearly every major mass extinction in Earth's history. How could a living ocean predator beat one of the grandest cosmic landmarks in an age contest? The scale of life. To understand this clash of timelines, we have to go back roughly 450 million years. Sharks have existed for roughly 1/10 of Earth's entire history. The earliest fossil evidence of shark ancestors dates back to an era long before the first plant ever evolved into a tree. Dinosaurs wouldn't even show up for another 200 million years. That means sharks had already survived multiple mass extinctions before Saturn's modern ring system may have even formed. The Cassini Nuance. For decades, scientists assumed Saturn was born with its rings 4.5 billion years ago. But in 2017, NASA's Cassini spacecraft did something no probe had ever done. It flew directly between Saturn and its rings. The results forced scientists to rethink one of the solar system's most iconic features. Using measurements of the ring's mass and remarkably pure, icy composition, many planetary scientists interpreted the data to suggest the rings might be surprisingly young, perhaps only 10 to 100 million years old. If this model holds true, when the first dinosaurs appeared, Saturn likely had no rings. For much of the age of dinosaurs, Saturn may have looked completely different from the planet hanging in our sky today. The broken moon hypothesis. So where could they have come from? One leading hypothesis suggests a violent, relatively recent cosmic event. A former icy moon, nicknamed Chrysalis, may have strayed too close to Saturn, crossing its Roche limit. Saturn's massive gravity tore the icy moon to shreds, grinding its crust into billions of fragments. If this hypothesis is correct, everything you associate with Saturn is actually one of the newest landmarks in the solar system, the blueprint of survival. While Saturn was slowly building to that orbital collision, how did sharks manage to stay alive down on Earth for nearly 500 million years? The answer lies in one of the most resilient evolutionary designs in biology. Unlike bony fish, sharks evolved light, flexible skeletons made of cartilage, saving energy and allowing immense adaptability. They developed specialized bioelectric sensors, the ampullae of Lorenzini, capable of detecting electromagnetic fields in pitch-black ocean depths. When giant asteroid impacts darkened the atmosphere, wiping out terrestrial food chains and driving apex predators to extinction, sharks adapted. They altered their diets, retreated into deep water refuges, and diversified into countless shapes and niches. While planetary structures were being shattered by cosmic collisions, sharks remained biologically bulletproof. Perspective shift. Put these timelines together and the reality is staggering. Sharks ruled Earth's oceans for over 350 million years before Saturn's modern rings may have formed. We assume cosmic landmarks are eternal while life on Earth is fragile. Yet one of Earth's oldest predators is likely older than the most iconic feature of one of the solar system's greatest planets. And the final twist? If the rings are young, they are also temporary. Gravity is dragging the ice down into the atmosphere through ring rain. In another 100 to 300 million years, they could be completely gone. If sharks survive the challenges ahead, one of nature's oldest predators may still be swimming long after one of the solar system's greatest wonders has vanished. Sometimes the oldest stories in nature aren't written in stone. They live on through the creatures that endured. If you enjoyed this journey through time, don't forget to like and subscribe for more deep dives into space and Earth's history. See you next time.